Okay, so we're looking at the Super Bowl victory. Chicago Bears punted a ball, followed the path which followed the function h of t equals negative 16t squared plus 40t plus 4, where t is in time, and is time in seconds, and h is the height in yards. So a lot like the catapult experiment. We're going to sketch a graph. I'm going to suggest that you get the vertex first. So we're going to get our a and b and c values. Our a value goes in front of is the coefficient of t squared, so that's negative 16. B is the coefficient of the t value, which is 40. And then c is 4, the constant term. The formula we use for the vertex is x equals the opposite of b divided by 2a. In this case, the opposite of 40 would be negative 40 over 2 times negative 16 equals 40 over 32. 2 negatives make a positive, or it's 1 point something. We'll just take a calculator and divide that out. 40 divided by 32, 1.25. Okay, so 1.25. I'm going to make a little table of values over here. We'll call that time and height. Try to get the vertex point in the middle. We know after 1.25 seconds we can get the height. To get the height, we're going to put 1.25 in for t. We're going to let the calculator do that. Negative 16 times 1.25 squared, yep, plus 40 times 1.25 plus 4. Make sure I copied that correctly. Negative 16t squared plus 40t plus 40. That looks good. Enter. 29. So it reaches a height of 29 feet. All right, well, I probably want to know what's happening at time 0. And maybe I'll pick a point to the left and the right. 1, and then, let's see, let's try 1.5 since we went up by 0.5s. All right, so one thing you could do is you could type it into, you could type the function into y equals negative 16x squared plus 40x plus 4. We'll look at the graph in just a minute. Well, actually, maybe we'll go ahead and do the graph. You can change your window. I know the window has to go at least, I see on the table, move this over a little bit. I see on the table that the vertex is at 1.25. So I'm thinking how many seconds a football will stay in the air. I don't think more than 5 seconds. Frame it in a little bit. Let's go -2 to like 7 seconds by ones. Remember, 29, I believe, is going to be our highest height. The lowest height would be when it hits the ground, which would be 0. -5 to like, let's go to 35 to frame it in. Scale of 5. Okay, and then we'll graph it. Ta-da, we didn't need so many seconds at all. Let's change the window again. Let's go to like maybe 3 seconds. There we go. Okay, now we can start answering the questions based on the graph. Okay, question number, oh, we have to do the graph now. We have to plot these points. Okay, you hit the trace key. We can type in 0. At 0 seconds, the ball is 4 feet in the air. Okay, at 1 second, 28 feet. 1.5 seconds, 28 feet. And I do want to find out where the graph, where the ball hits the ground, so I'm looking right here. That's a 0. So we'll do second trace 0. The other 0, by the way, doesn't make sense in the context of this problem, left bound. Enter right bound, enter the guess. Make sure you see that. 2.596, we'll round that to 2.6 seconds, 0. Okay, then you can plot your points. So we got to get out to like 3 seconds. 1, 2, 3 seconds. And maximum height of 29, so maybe we'll go up by 5s. 15, 20, 25, 30, and this is height in yards, and this is seconds. Okay, so plot your point, 0, 4, 128, 1.25, 29, 1.5, 28, and then like 2.8 seconds, 0. So we got our shape. Okay, now we're going to start answering some of the questions, and we're going to use the graphing calculator to help us. What's the value of the y-intercept? You can see it here, 0, 4. This would mean, move this out of the way for a second, 0 seconds, 4 yards. That does not seem really reasonable to me. Yeah, 4 yards is like 12 feet. You know, I think that maybe this should not be yards. I'm thinking this should have been a feet. Even that's a little high. I guess a guy could kick it 4. Yeah, I think that seems reasonable. Change that to feet. That can't be yards. I can't imagine a guy kicking 12 feet up in the air, getting his leg that high, unless he was a giant. How high was the ball after 1 second? We got that off the table too, 28 feet. How long did it take to reach the maximum height? Maximum height here. Here is the maximum height. That was 1.25 seconds. 29 feet is the maximum height. If nobody catches the football, how long will it take to hit the ground? About 2.6 seconds. The longest hang time. Amount of time a ball's in the air after punting a Super Bowl is 2.76 seconds. Did the Bears punter break the record? No. After how many seconds is the football 20 yards in the air? Okay, this one you can do on the calculator. Y equals, you can type 20 in for the output, because that's 20 feet, so that's our output value, which is Y. You can graph that. And now we need to find these 2 points. So we'll do second trace intersect. Enter, 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 enter. Will get us the first one, 0.5 seconds. And second trace intersect again. Enter, enter. But this time make sure you move your cursor over to the other intersection point. Enter, enter, 2 seconds. So 0.5 and 2. 0.5 seconds, 2 seconds. Why does this make sense? Well, what do you think? As something goes up, it's got to come down again. So it's gonna reach a height of 29. It's got to go through every value between 0 and 29 to go up, and then every value from 29 to 0 to go down. That's called the intermediate value theorem, which we study in calculus. What's a reasonable domain and range for this situation? Okay, well, this is a real-world situation, so we will be limited to our bounds. So x is time. Our lowest time was 0. Hit the ground at 2.6 seconds. And then the range is the time. By the way, that should be t, not x. Output is the height, and that was a high of 29 feet to a low of 0 feet. All right, so that's how you'll do that.